Hello all, welcome to another session with me, Varun on Tech Tablet. In this video, we would be discussing the second part of the third unit, wherein the name of the unit is Data Handling and Visualization in R. Now let us just take a look at what syllabus we have in this unit. In this unit and in the second part especially, the first topic that we would be looking at visualization with ggplot 2. The second one would be grammar of graphics and aesthetics. The third one would be geometries and scales. The fourth one would be visualizing categorical and numerical data. We all know that data exists in different types, but one of the major classification is numeric variant of data and a categorical variant of data. We'll see how to handle these. The fifth one that we would be looking at is how to facet and layer, or faceting and layering, like we all very famously call it. And finally, how to customize and export your own graph or your own plot onto the surface or onto the front end or onto the non-coding arena. We'll see how to do that. So just to keep it very simple, I think today we would be looking a lot into ggplot2, which is your major library for data visualization in R. Okay, so this is the library that we would be focusing on, especially in this video. So now, to visualize with any library, firstly, you'll have to download the library and install the library. Okay. Having said this, the most famous and the most sought after library is ggplot2, as you can see here on the screen. G stands for grammar of graphics. I think here you can see the definition or the abbreviation of ggplot. Okay, so we're trying to define the grammar of graphics to generate a plot, just to keep it simple and easy. Now, what are the features that this library gives us? So the first of all is it gives you the grammar of graphics, like the name itself says. So what does that mean? It means you would be able to layer multiple plots using this layering system that we have available. Now, having said this, you also have aesthetics, which is represented with AES. Okay. Now, what do aesthetics do? They map the data to the visual properties. Now, here, let us say you are able to see a graph on one side of my screen, which goes like this. Now, how is this graph generated? Now, I want this graph to be in blue color. I want it to have dots as in when possible. I wanted to be able to generate different, designs. So all these are possible when I use AES. AES is aesthetics, right? And then the next one that we have is geometries. Now, what do geometries do? They choose the visual marks, okay? Now, here you can see you have dots. Now, instead of a dot, maybe I want a rectangle or a triangle at each and every location. In that case, I would be able to change it using the visual marks in geometry. And then you have scales. Scales, I think, is one of the most important. Now, whether you want your graph to be in this boxed size or whether you want your graph to be in this size is something that you decide with the scales. Okay. Now, this could be 10 centimeter and 10 centimeter, while this could be 50 centimeter and 30 centimeter. Now, that depends on your requirement. All right. So now, just to summarize what we have here, ggplot is built on grammar of graphics, which is a framework. Okay. Now, next time, if you are asked about ggplot2, now you know what to answer. And it also combines data, which is multiple. Okay. It also combines the data, it combines the aesthetic values, it combines geometric aspects of the information. Now, when you have all these, you would be able to make it better or give it a better look and feel using properties like color, shape, and size. These give you the features. I mean, these features give you the capacity to edit the graph. And geometries, it defines the type of plots or points or lines, etc. All these can be defined there. So here I have a very small code that I've exclusively downloaded or used for you here. Please remember, iris data that you see, it's an inbuilt data. And if in case you want to work with this data, then I think you should, you can directly say IRIS, hit Control Enter, and you should be able to see the data set in your system. It's because it's an inbuilt data set. Okay. So I would be, after installation, I would be instantiating my library in the first place. The data that we are using is Iris data. It's a very famous data set. I don't think it needs any explanation or it needs any sources. You can just go to any Google or any website and just type in, Iris data set, and you should have the answer. Or you should have the data set with you. I mean, if it is not available in your system, just in case, which is not a probability, but still, then you can download the data always. Now, what I'm doing is I'm considering my X values and Y values to be the sepal width and sepal length. Okay, I'm specifying a color. The color would be species. So how many ever species I have, I would be able to see those many different colors that are being generated. And I want this to be geom point. Geom point. Now, what do we mean by a geom point? Now, if in case you do this, you will be able to see the answer. However, geom point is for a scatter plot. So whenever you're working on a scatter plot, we use geom point. Okay. Now that I have added my x-axis, y-axis, and given the colors, now I would be using labs. Labs is nothing but labels. Okay. Now what labels do you want? Now what is a label? Your x-axis name or your y-axis name, all these, they fall into labels. Okay. So here what I'm doing is I'm giving my graph a title, the name for x-axis and y-axis. Now with this, I have my first ggplot2 graph, which is ready to be visualized. If in case you have actually done that, I would really appreciate if you could take some time off to paste the image in the chat section below. Now, faceting and layering. What do these mean in the first place? Now, when we talk about layers, please understand that I might have two graphs. Now, this is a bar graph, and on top of a bar graph, I have another graph, or probably on a histogram, I have a line graph that I'm using just to check. Now, is this not a layer wherein I'm having one graph on top of another, on top of another? And I could also use, geom underscore star to give multiple layers. I can also use stat underscore star for multiple summaries. Okay, so this is called layering. Now, what do we mean by faceting? Faceting is giving multiple panels. Here, they are not arranged one on top of another. They are arranged one beside another. Right? Now, here, this example that you see, I think this is a perfect example of facet. Okay. In facet, you're able to see all the graphs very clearly and distinctively. All right. So now let's understand each of these. So when we talk of layering, okay, so till from here to here, we have layering and then we have faceting. So let's understand these. Now, when we talk of layering, in ggplot2, it allows you to give multiple functions that can be stacked on the same plot. Please remember this. Now, what does it do? It basically gives you a richer visual storytelling. So you have multiple inputs on the same graph. You can look at the graph and you can compare all of them in the same in one instant go. And you can use geom point along with geom smooth, which means I can use a when we say geom point, what do we mean by a geom point? It's a scatter plot. Geom smooth gives you a line graph. So I'm using a scatter plot with a line graph to show raw data and the trends. Now, what do we mean by faceting? Faceting is, as you can see here, a single plot is gone into multiple panels. So you would be using facet wrap to ensure that all these multiple images that you have, they are all wrapped under one image. Okay. So this is the difference between them. Here I have given a very decent code explanation as well. And all those of you who are learning R for the first time, I always keep repeating the same thing. Pause the video, take down this code, try to work it out, and then go to the next part of the video. You can always pause and play, right? So here I have ggplot2, which is my library, and data is MPG. I think this is information from cars data. Cars data is also very easily available on any platform, and I think this is also inbuilt in R as well of late. Now, what am I doing here? I'm considering my cars data, taking my x-axis and y-axis, using geom point. Now, we all know what's a geom point. Then I'm using a geom smooth, which is a line graph. And here you can see LM. LM is a linear method or linear model. Okay. I'm giving LM, which is a proof that it's a line graph. Then I'm using a facet grid or a facet wrap. I mean, a facet wrap is a part of facet grid. And in facet wrap, I'm giving it a property, or I'm giving it what variant do I want. And on top of that, I'm giving the names for my x-axis and y-axis along with the title of my graph. So this is how I can, kind of design my graph step by step, all enclosed within single code. Now, please remember, this whole chunk is just one piece of code. It is not 5 to 6 pieces of code. It is just one piece of, not codes. I think it is one piece of code, singular. Okay, why? We know that because I'm using a plus here. If you can see, what does this plus mean? It means that I'm connecting the upper line of code to the second line, to the third line, to the fourth line. So they're all one part of the execution. Then we have the most important topic. Though we all know how to generate graphs, we do not know, or we lack an idea of how to generate visually. Like, what is the difference between a categorical graph and a numerical graph? Now let's look at that. We all know what is a category. Now let us say I want to count the number of oranges and mangoes. We go with categorical graph. Now, if in case I want to check how many boys are coming at a time and how many girls are coming at a time to a certain hotel or to a certain restaurant, so I can calculate the incoming and outgoing population of my store for women and men separately, then I would go for numerical data. Okay, so categorical data and numerical data, the data in itself is a bit different. However, what are the graphs that we use for categorical? So the first one is a bar graph. The second one is a pie chart. The third one is a stacked bar. So the first one and the second one are both variants of bar charts, while the third one, pie chart, is another variant. Let's talk about each of these graphs as we go ahead, but right now, let's restrict to this. Then we have numerical data as well. And for numerical data, we use a histogram, we use a density plot, and we use a box plot. All of these graphs are meant for different purposes, and let us understand what they are right now. So firstly, choosing a graph is completely your decision. It depends on your discretionary power. And for categorical graphs, we use bar chart. Now, what is a bar chart used for? Bar chart is used, okay, I think we have it here. I don't have to write. Bar chart is used for comparing values across different groups. Now, India has 5 bowlers, 5 batsmen. Australia has 5-5. Let us say Kenya has 5-5. Zimbabwe has 5-5. Now, I want to compare how the bowlers and batsmen are performing. Now, in this case, I would use a bar graph. Okay. Now, going further, then we have a pie chart. Pie chart is used to show proportions and not to compare. I mean, comparison can happen within the plot, but we are not trying to compare two groups. We are trying to compare the proportion within one data set, right? Now, for numerical values, we have histogram, which is the first. Histogram, what does histogram talk about? It reveals distributions, or you would be able to, check and understand the frequency of the information. Okay, just using easier terms for better understanding. Then the second one is a density plot. In a density plot, we use a smooth distribution curve. All right. The density plot is, again, just to keep things easy, it is more of like a smooth line graph. Okay. Then we have a box plot. Box plot is used to summarize the spread and outliers. And what does a violin plot do? Just add density into box plot and you will have a violin plot. Now, violin plot gives you a good density graph along with box plot. So it wouldn't be wrong to say a violin plot is equal to density graph plus box plot. Simple. So the more you look into graphs, the deeper understanding you will have about them while working or while practicing. Now here I have used a very simple example of a bar graph, of a categorical graph and a numerical graph. For categorical, we are using a bar graph, and for numerical, we are using a box plot. Okay, so the first one, as you can see here, what are we doing? We are trying to work on one box plot, which is this, and we are working on one bar graph, which is this. Okay, now what are we doing in a box plot? Again, here the data is equal iris data set. Okay, very famous. Within this data set, I'm considering my x-axis and y-axis to be species and sepal length. So basically, I'm trying to see the sepal length of different species. Now, what are the different species? You have, now where is species? It says x-axis. So within my x, whatever I have are my species. So A, B, C, and D are the four species that I have. And here at the top, we have the readings of a box plot. Then we have a bar graph. Now, this is a bar graph. And what does a bar graph do? It compares values. So, like you can see, I can say that this last value is higher than any other value. Okay, the third value is lowest than any other value. So, you could just compare values from one graph to another. And this is exactly what graphs do. Finally, you have how to customize and export your plot. In order to customize your plot, there are many options available. The first one is themes. You can use different themes. I'm sure you all know what is a theme. You can add label and titles. We've just seen how to add that. If in case you've done the coding, then you have an understanding. We can use labs. We can use axis. We can use title. There are many functions, or there are many inbuilt functions that we can use and generate this kind of a graph. Then you have colors and palette followed by export. Now, whenever you want to export a file to save the file, it could be the whole file, or it could be just working on saving the graph. Right now, we're talking about saving the image or the plot only. And to this, you would be using ggSave. I've already mentioned it here in the slide. Now, what does ggSave do? ggSave, it basically gives us a couple of things. The first one is it saves the image in whatever format, size, DPI you want. And once your plot is ready, it allows you to export the information in a very high resolution format. Okay. You have PNG or PDF in which you can get the image exported. Notwithstanding this, you can also specify elements like height, width, DPI, etc. Just like I said. Okay. And how to customize that? You don't have to go through the whole code. I mean, going through the whole code would be the best thing that you can do. But if you're not able to do that, then just check out the last property that we have. Okay. And when you check out the last property, you would realize that here I mean, there's not a lot that you have. Almost all these values are something that we have generated, except for the caption, theme, and the color scale brewer. The rest all values is something that we have seen till now in the last slide, right? So if in case you have the code with you, you just need to add a couple of more lines and get the output. And how do you save it? Here you can say, I want to save the image with the name mycustomplot.png. The plot is P, which means this variable would be going in as the input. The width of the output would be 8, the height would be 6, and the DPI would be 300. Now, what is DPI? DPI is dots per image. Okay. Now, basically, it is this DPI that gives you a deeper understanding of how good or how high resolution your images are. DPI generally goes from 72 to 600. Now, if it is 600, then it is probably of the highest quality, right? And here we are using 300, which is considered a really good high resolution quality if you're not looking for printing or publishing. Okay. So this is what we have in unit 3. So with this, we have completed unit 3. We have understood very deeply about what is a data frame, to what are plots and how do we generate the plots. Okay. In the next part, we would be beginning with unit 4. And in unit 4, we would be understanding the other aspects that we have within the unit. Now, if in case you have any queries or any doubts or any questions that you need to ask, you know what to do. There's a chat section, there's a chat right below your video. Pause the video, ask the question, and then you can continue looking, and I will revert back to you at the earliest. Thank you very much for watching. I hope you have really understood. You all have a great day ahead.